Hello, Pre-Calc. Today we are going to be starting Chapter 2 in the calculus book. You do not have a calculus book, but I will be posting the calculus book. You really don't necessarily need the book. We've made all the assignments into worksheets, so but just, to have on hand, I do have the Chapter 2 from the calculus book as a PDF. So I'll be posting that in Canvas so that you can take a look at it if you need examples and things like that to help you, vocab words, extra problems for practice, that type of thing. So all of that will be in Canvas, as well as all of the note sheets and all of the worksheets for this unit will be posted on Canvas. So you can find all of that there. We are doing the day 1 notes today. We're actually just going to do the front side of the notes today, and then we'll finish up the back side tomorrow. We're going to be talking about something called limits. All right, now ideally we would have normally done a little bit of chapter 13 before this that would have kind of talked about limits a little bit, but limits in general are going to be having you look at graphs. All right, and a graph is, if you have some kind of a graph like this, limits are going to be as you approach a specific x value, what are the y's getting closer to? Oftentimes the limit will be whatever the y value is at that x value, but sometimes there will be graphs where maybe there's like a hole. All right, and so like the limit as x approaches 1 will be a specific value. But if you were to look at the y value at x equals 1, it might be a hole. It might be undefined. All right, so limits are going to be what you're approaching, not necessarily what that y value is equal to at the specific x value. I'll show you some examples as we get into these. We're going to look at, we're going to use our calculator to graph sine of x over x, and we're going to find the limit as we approach 0. All right, so first off, we're just going to go to our calculators and we're going to type in sine of x over x. All right, so sine of x divided by x, and we're going to graph this thing. All right. When you hit graph, I might have to adjust my window. Yeah, so what I need to do is you want to make sure that you are in radian mode. All right, and I have my graph here. I'm going to change my window a little bit. I think I'm going to go from like negative pi to positive pi. I think that should suffice. So negative, we'll do pi to positive pi. And we don't need to go all the way up to 10. We can just do like negative 2 to 2. All right. And if we graph it, you get a better look at the specific part of the graph. All right, so I'm going to draw a picture of it. All right, so the picture of my graph is, your typical sine curve. It looks something like this. All right, so there's my graph, but we want to know what value the graph is approaching when x equals 0. All right, so what we're asking for is what are the y values getting closer and closer to as you approach x equals 0. We're not actually asking what the y value is at x equals 0. We're asking what the y values are approaching or getting closer to at x equals 0. All right, what you want to do is you kind of want to look at the table real quick. All right, if we go to the table, we go to second graph, and we go to where x actually is equal to 0, you're going to see that it's an error. All right. So as you can tell, at x equals 0, it's undefined. There's actually a hole right here. All right, it's kind of hard to see when you graph it, but by the table you can see that there's a hole there. So at x equals 0, the graph itself is undefined, but the limit is not what we're looking for. We are looking for what the x's or what the y's are getting closer and closer to as we approach x equals 0. All right. Limit notation is going to look something like this. You're going to see lim for limit. As x approaches c will change depending on what the problem is, of f of x equals L, and L will be whatever the limit is. Here's how you say this whole crazy thing. All right, the limit as x approaches some value c of f of x is L. Okay, the limit as x approaches some value c of f of x is L. All right, and so what we're going to be finding out is the limit as x approaches 0 of sine of x over x. And if we look at our table, you can see that the y values right before it are getting closer and closer to 1. All right, and you can see that the y values on the other side are also getting closer and closer to 1. And hopefully that makes sense. As a typical sine curve, usually you would have a high value at 0, 1. So the limit as x approaches 0 of sine of x over x is going to be equal to 1. All right, this is going to be very important for you to know. We're going to use that common limit quite a bit. All right, so hopefully that makes sense. We're going to move on to down here. Identifying limits from graphs. Okay, so what we're going to do is we're just going to draw some graphs. All right, let's say that at 2, -2 you have a hole, and then the rest of it looks kind of like a parabola. All right, and then let's say for the next graph we have a hole at 2, -2. Once again, we have a parabola, and then at 2, +2 we have a point. And then let's say for this graph we just have a minimum at 2, -2, no holes in this one, and the parabola opens up. Okay, we're going to look at the limit as x approaches 2. Okay, the limit as x approaches 2 for all three of these graphs. If you look at all three of these graphs, all right, as we follow the curve and we get closer and closer to x equals 2, we're approaching this lovely little hole. But the y value here would be -2. All right, it's not what is the y value at -2 or at +2, because that would be undefined. It's what are the y's getting closer to as we approach x equals 2. So these are getting closer and closer to a y value of -2. If we look at this one, as we approach 2, whether we go from the left side or the right side, we're getting closer and closer to, once again, -2. Even though there's a point up here, the graph itself is here, and we're approaching this low point here at a y value of -2. And even with this graph, as you approach x equals 2, whether from the left or the right, you're getting closer and closer to this minimum, which has a y value of -2. So the limit as x approaches 2 for all of the graphs is going to be -2. All right, is -2. All right, so you kind of have to look at those and look at the graphs. Graphs are going to be really important. All right. There are some more properties of limits on these specific pages in your pre-calc book. All right, you do have your pre-calc books, hopefully, so you can look at those. All right, what we're going to do is we're going to find the limit of these guys down here. One of the fastest ways to find the limit is to substitute the x value into the expression to see what you get. Sometimes that won't work though. If you take the x value and plug it into the expression and you get something that's undefined, then that doesn't always work so well, and you may have to do some factoring to get some things to cancel out. You may need to look at the graph to get a better idea of what's going on. So there'll be different things that you'll need to do. Let's start with the first one. So for this, what you can do, you have two options. You can either factor the numerator. All right, so you could say you've got the limit as y approaches 2. In the numerator, we can make this y plus 3 times y plus 2. All right, and in the bottom, we have y plus 2. And these are going to cancel, giving you the limit as y approaches 2 of y plus 3. And then you can just plug the value in. All right, if you plug in 2 into y, you'll get 2 plus 3. All right, so you would end up with 5. All right, you can just plug the value in. All right, because if you plug in 2, you're going to get 5. The other option, if you don't want to factor and cancel things out, is you can just plug in 2 right away. If you plug in 2 right away, you square the 2 plus 5 times 2 and divide, you will get the same value. You'll still get 5. Okay. For number 2, you've got the limit as x approaches -1 of 2x squared plus 2x all over x plus 1. You're going to want to plug -1 into x. The problem with this one is when you plug in -1 into the denominator, it's going to make it undefined with a 0. So this one, we're going to want to factor, kind of like what we did with the last one. If you notice, we can factor out a 2x out of the numerator. We get x plus 1. And in the denominator, we have x plus 1. These are going to cancel out, leaving you with the limit as x approaches -1 of 2x. And now you're just plugging it in. All right, if you plug in -1, 2 times -1, you're going to get -2. All right, much easier to work with once you get the denominator cancel out. This one, the limit as x approaches 3 of 1/2. You can't do any factoring, you can't cancel anything out, and there isn't even an x to plug the value in. Here's essentially what's happening with this one. If you think about the graph y equals 1/2, y equals 1/2 is going to be a horizontal line. All right, and x equals 3 is going to be somewhere around here. All right, whether you're approaching x equals 3 from the left side or from the right side, your y values are just remaining 1/2. No matter which way you're going, the whole way along here, your y value is still going to be 1/2. So when you have something like this where you can't even plug it in, the limit is just going to be that value, which is 1/2. And hopefully that makes sense. You can see that the y values as you approach 3 are approaching and or staying at 1/2 the whole way. Let's see. And then number 4. Okay, we've got x approaches -2. All right. What we're going to do is I can't do any factoring, so I'm just going to plug it in. All right, so the limit as x approaches -2 of -2 minus 25 to the 2/3. All right, we're going to end up with -2, or -27, I apologize, to the 2/3. All right, now to do this one, all right, what you can do is, this is the same thing as -27. I'm going to rewrite that as -3 to the 3rd. All right, and then still raised to the 2/3. And the reason why I did that is because now when you have a power to a power, you multiply. The 3's are going to cancel, giving you -3 to the 2nd. And -3 to the 2nd, that's just going to be 9. All right. The other way you could have done this is, you can remember with exponents and stuff, you can think of this as -27, or the cube root of -27 to the 2nd. Either way, you're going to end up with 9 for your answer. Okay, so limits are going to require you to really remember how to graph different things and be able to plug values in, and also be really good at factoring. All right, so that's kind of the start of limits. We will finish the back side of the notes tomorrow. All right, in the meantime, you can start the 2-1 day 1 worksheet, and then tomorrow you'll finish that up. All right, thanks.